I'm Carly Kaufman. I'm Head of Solutions Architecture here at Fishtown. And I want to just tell you a little bit about my background before joining Fishtown. My love affair with DBT really began back in mid-2018. I had just joined a small Denver-based company called Artifact Uprising, and I was head of their BI, which was really just a team of one, as many of you probably are. And I was tasked with rebuilding all their BI capabilities. They had all of their transformations built in Looker as PDTs, and it was a bit of a mess. And just my background prior to joining Artifact, I had really only used enterprise legacy ETL tools, things like Informatica, SQL Server integration services. And of course, a small company can't afford those tools, nor do they want to move to Microsoft. And so I started Googling, like, how do I build custom ETL scripts? And I'm learning about Python and all these things. And I land on a blog by Tristan, our CEO, who hopefully you'll attend his keynote, I think, tomorrow. And it's this blog talking about DBT, and I'm like, oh, this looks pretty cool. And then I find this really, really low quality YouTube that Drew, our other co-founder, had put together explaining how to get up and running with DBT. So I followed his tutorial and was really up and running within a few days, and thus began my love affair with DBT. And for the next 2 years, I implemented it at my company, and I like to say it kind of put me out of a job. Whereas the company didn't let me go, I kind of ran out of things to do because DBT just made my life so much easier. And eventually I just said, well, I want to just go work for the mothership. So here I am. I'm at Fishtown doing solutions architecture, which means I'm doing our technical implementations for our enterprise sales teams. All right. So today I want to talk about, how did we get here? A short history of ELT for those of you who aren't familiar. And then what is DBT? And finally, just talking about some DBT core concepts that I hope you'll take away today and use with you the rest of the week. And then we'll have plenty of time at the end for questions and conversation. I'm not looking at the Slack channel right now because that would be distracting, but please do post questions in there throughout the presentation, and Claire will be sure to interrupt me if needed, and I'll pause for questions throughout the way. All right, so how did we get here? Back in 2010, 10 years ago, the focus of many analytics teams was on things like infrastructure, compute, and storage for large data sets. These are not the most exciting topics if you're an analyst, but it was things that were necessary in order to make sure that your BI platform performed. For questions like controlling storage costs and designing performant data warehouses, we had Kimball data warehouse architecture that would seek to address those 2 points. But these were just not problems that we really wanted to solve, and we ended up involving infrastructure or DBA teams to help us out. But today, as we've shifted towards ELT and we have unstoppable warehouse technology, many of those issues have been addressed. Moving data into your warehouse is now extremely easy if you're using a tool like a Fivetran or a Stitch, and it automates that data ingestion process. And then our warehouse technology has just really removed that infrastructure overhead. Storage is cheap. We have credit-based payments and managed query engines, and Expressive SQL removes the need for transforms to live in Python. However, the problem with this is that data modeling, it still looks the same as it did in 2010. You really have 2 options for modeling your transforms. One would be custom code in Airflow. This can be very expensive because you're having to hire people that actually know how to write this custom code. It's inaccessible because everything is now in Python. And these data sets can be really slow to build. They can take 3 to 4 weeks, sometimes longer, for a new feature to get out. And it requires a ton of in-house infrastructure. On the other side, and this is where my background really came into play, is you'd have UI modeling. This is also really expensive just due to the pure licensing fees and having to have another server sometimes to support this. There's also a really steep learning curve for using these tools. You often hear or look at somebody's resume and they're Informatica developer, and this truly is what their entire career is because it takes so long to use this tool. I was an Informatica developer a long time ago as a consultant, and it probably took me 2 or 3 months to really get intermediate at the tool. These tools can also be really slow. To express something like an outer join or a lookup, you have to pick a different widget on the screen to do that. And then they don't have any version control or testing built in either. So these old methods of data modeling really ruin that dream of democratized data access. Data sets are slow to build. Customers don't have the data they need and trust, and they don't trust what they do have. And BI adoption across the board tends to be low, except for teams that have made huge investments in their BI infrastructure. And this can be really frustrating because a company will spend so much money, buying all these ETL tools, these reporting tools, and then you still have analysts and business users copying and pasting SQL and running it against the database because they don't trust the data. DBT really tries to address all of these issues with two core principles. Number one, anyone who knows SQL can author their own data pipelines. And their tools should enable them to work like software engineers. Software engineers have like all these cool things like version control, testing framework, test-driven development, documentation, code reusability, continuous integration and deployment, and native logging and alerting. And as SQL developers, we've just never had those cool things, but now we can have them. And we call this practice analytics engineering. Now, before I jump into the meat of the presentation, for those of you who are new to just ETL or ELT in general, you might be wondering, well, why do I need to transform my data? Why can't I just load it into my warehouse and use my reporting tool to transform it or write custom SQL? Transforming your data does many things, more than I've even listed here, but a few things I want to point out that it's useful for is cleaning your data. This would be things like standardizing data types or just cleaning up data that's kind of ugly. Deduping data, especially if you're pulling data from multiple source systems, this is where you would do that. You might want to restructure your data to be in a more friendly reporting format. For instance, combining things like orders and order lines into one data set. Filtering your data. Oftentimes our source systems have deleted records. You might want to filter those out for reporting purposes. And you'd also aggregate your data at this level here, doing things like creating measures for number of orders, or sum of revenue. And finally, you would join your data to other data sets at this level. All right, so moving in to the real presentation. So what is DBT? DBT is an open source transform tool that allows anyone comfortable with SQL to author their own data pipelines. And I'll probably repeat this a few more times during this presentation. So where does DBT actually sit in your overall stack? On the left side over here, you have things like your data loaders like Fivetran or Stitch, and that loads your raw data into your warehouse. And this would be the E and the L of ELT. And in the middle here, you have some type of hopefully modern data warehouse like Snowflake or BigQuery or Redshift. And on the right side, you've got tools that consume that transform data like BI tools, data science, and maybe even your rogue query. So how do you get from raw data to transform data? That's where DBT sits, right here in the middle. DBT just acts as an orchestration layer on top of your warehouse. It's pushing down your code to your warehouse versus traditional ETL tools that do it in memory. Now, the benefits of pushing down your code is that it's more secure. You're not moving data over the network. It's faster. It can be up to 10 times faster because, again, you're not moving data over the network. And it's much easier to maintain. You only have one set of servers to maintain, not this special ETL server. DBT is open core. Throughout this week, you're going to hear words like DBT Cloud or open source or DBT Core, and I want to just clarify the differences between those two. On the left side, we have DBT Core. This is our open source data transformation tool. This is what we've been building since 2016, and many of the community members have helped us build. And this includes our core SQL compilation logic, Jinja templating, and all the database adapters you'll need. And you would interface with this tool via the CLI. This is our free tool. It's always been free. It always will be. And it's what so many of you are so excited about. On the right side is our DBT Cloud. Now, this is our fully managed DBT experience, and it's in a SaaS platform. So it really sits on top of DBT Core, but includes things like a full IDE for developing and testing your code. You get things like job orchestration, logging and alerting, integrated docs, and user authentication. And DBT Cloud starts at free for a single developer all the way up to the enterprise level, which is where the space that I work in. So talk to me if you want to talk enterprise. All right, so there's five core concepts I want to make sure you walk away with today. First, you express all of your transforms in DBT with SQL selects. We automatically build your DAG using refs. DBT includes a built-in testing framework, which ensures that your models are accurate. Your documentation is accessible and easily updated. And finally, you can use macros to write reusable SQL. All right, first core concept. Everything in DBT is a select statement. Because of this, there's no need to write boilerplate code. Many of you might be writing things like create table, create view, drop if that exists. You don't need to do that with DBT. You get to focus on the business logic, which is what we're actually really good at. Because of this, you achieve idempotence. This allows you to have repeatable builds. I didn't even know this word existed until I joined this company, but now I'm finally able to say it without messing up. And with this, you can materialize models with different configurations, views, tables, CTs. And this really allows your transform code to be very, very accessible because anyone who can read SQL can actually understand your transform code. So what does this look like in DBT? On the left side is what we call a DBT model. Now you may be used to model meaning something like a data model, which is many, many objects. In the DBT world, a DBT model is one-to-one with a database object. So think view or table, something that lives in your database is a DBT model. So what you do is at the top of your SQL file, you would simply write config materialized equals table. You write your simple SQL statement. And then when you click DBT run or type DBT run, what actually runs in the database is this fancy create table statement. And it surrounds that select statement for you. In addition to tables, like I mentioned before, you have views, you have ephemeral models, and this is just a fancy word for a common table expression or a CT, and it allows you to interpolate one model in the other. And this is really great for organizing your code. We have incremental strategies. This allows you to do something like a selective rebuild based on a timestamp or a unique key. And finally, because our product is open core, you can actually build your own materialization strategies. We have many clients that say, you know, the way you've built it doesn't work for our requirements, so we're just going to take yours and build onto it and make it work for us, which is great. I'm going to pause here for any questions. Do we have anything, Claire?
We're all good so far, but yeah, if you have any more questions, keep them coming in and we'll relay them back to Carly as we keep going.
All right, core concept number 2, expressing relationships with the ref statement. So this ref statement allows you to do 2 things. First is it interpolates the name of your schema. This allows you to move between dev, prod, and test really easily. In my past, when you would build out your data warehouse scripts, you'd have one for prod, or you'd have one for test, and then you would do a find and replace in the script and replace test with the word prod. And then that's how we would do our deployments, and you'd hope that you got all those find and replaces correct. With DBT, you don't have to do that. You just write your code, and DBT can handle all your environments because these are all just configurations. And then the second thing the ref statement does is it builds an edge in the DAG between those 2 models, which helps DBT understand these dependencies. And you would just select from it like you would any other table. You just wrap your model name. Again, model name could be like a table or a view, and you just wrap it with this fancy ref statement. And the ref statement is Jinja code behind the scenes. So here's an example of this. What I want you to look at is this miniature little DAG up here. In this example, the orders model is dependent on base orders running first because orders is going to select from base orders. So to achieve this in DBT, here's your orders model. It's just an orders.sql text file. You just write your select statement, and then you select from the base orders table. However, you wrap it in that ref statement. Now, when you compile your code, DBT says, oh, I'm in the dev environment. Okay, I need to compile this to analytics.dev.base orders. And then it's building that red line, that relationship between those 2 objects. All right, now we actually get to see a demo. So in DBT, let me show you a really cool version of that screenshot. This is what a DAG would look like, or a lineage graph would look like in DBT. This is all auto-generated for you. In a typical production environment, you might see hundreds of models in here. This is our demo environment, so it's very simple. What I'm going to show you here is if I click on the orders model, again, this is probably a table or a view that we've created in our database. The orders model is dependent on all of these models running before it. So DBT knows, okay, I cannot run order product until I've run everything before it. And what's really great is that DBT knows, oh, I can also run these in parallel. So instead of running order product and order, then product, it's going to run these three in parallel. But once it gets to order product, it knows, okay, I need to wait and then run order product and then continue on down this pipeline. And most of the legacy tools I've used, I've actually had to draw these lines between the objects. With DBT, it's almost a little bit backwards. You're writing the SQL, you're creating the relationships, and then DBT is generating this lineage graph. I know that might be a little crazy for some. Does anybody have any questions about this?
Yeah, we just had a couple questions. I'm going to answer the first one. So there was a question around how do we create dependencies between DAGs. In Airflow, there's a great concept of sensors. So I think sort of in DBT, all the dependencies are just managed through that ref function. You can schedule like different parts of the DAG at different times. That's sort of more of an advanced thing that we'll pass a link on to outside of this DBT 101. There's another question that I think, Carly, you'll be great to answer. So how are these DAGs actually scheduled? So we're talking about going through and DBT being able to run all of it. How do we actually tell DBT to go and run on a schedule?
Yeah, so I wasn't including that in my demo today, but I will at least just talk to that. So we have a job scheduling feature in DBT Cloud, and you simply type the commands that you wish to run. So if you've used open source, you probably haven't because you're here today, so never mind. But to run this whole DAG, you simply type the command dbt run, and it knows to run all of these models in the order that the relationships have specified. There's different selection syntax if you want to limit it to a subset of those models. But in general, that would be the command you would use. And then you would just create a new job and you tell the job, run the command dbt run, you'd schedule it, and then you'd be on your way. I saw a couple questions in our chat on StreamYard. Somebody asked if DBT Cloud would be free and open sourced one day. You know, I can't speak for our co-founders, but as a member of our enterprise sales team, I'm going to say no. You know, DBT Cloud is actually how our company makes money. So if we made it open source, it probably put me out of a job. So I'm gonna go with no for now.
Yeah, I think that's right. There is a forever free tier though of DBT Cloud. Yes. So free in the sense of a free beer, not free as in freedom. Yeah, there is a free tier, but yeah, we're a company. We have proprietary software, and that's okay. So yeah,
but the open source DBT core will always be
absolutely always open source.
Okay, awesome. Any other questions?
I had a quick question. So we're in DBT Cloud with this lineage graph. Can you do this in the open source version as well?
Yes, you can. You can. It would if you were working locally and then you generated your lineage graph, it would just pop open in your local host. But plenty of our clients just host it on a server somewhere.
Yeah, absolutely.
Yeah, so this is included with that.
Awesome.
And actually, I think everything I'm showing today is included with open source.
Yeah.
The job scheduling would not be included, but I'm not demoing that today. All right. Great questions. All right. So core concept number 3, easily build tests to ensure model accuracy. Unfortunately, this is kind of a one-way conversation. I don't know about you all, but in my past, the way we tested things where we kind of spot check things in Looker, make sure the numbers looked right, make sure that our build didn't fail, and then just hope that you didn't get any Slacks or emails the next morning. I, in my past job, woke up many times to a 6 a.m. email from our CEO saying, hey, margin doesn't look right for yesterday. Can you look at this ASAP? And I'm suddenly on my computer, before I've even gone to work, back when I used to go to work. But now with DBT, you can get ahead of this and hopefully get those notifications in the middle of the night if you need them, and then your boss won't even know. So to do this, DBT has this out-of-the-box testing framework, and it's really simple. You write test assumptions in a YML or a YAML file, and out of the box, you can test if a column is unique, if it doesn't contain nulls, if it contains certain accepted values, and if it's a foreign key to another table. And this foreign key test is really interesting because modern data warehouses don't have that built-in referential integrity that you may be used to from like SQL Server or Oracle. And with DBT, you can still kind of build that in. And with this testing framework, if any of your tests fail, you can prevent the downstream models from running. So this really prevents you from loading bad data into your data warehouse. And when a test fails, it'll notify you via Slack or via email, hey, I failed. So if you really want to know in the middle of the night if something failed, you could set up all of your alerts and wake up in the middle of the night, fix it. Nobody will know the difference the next morning. And finally, with our framework, you can test really anything that can be written as a query. So let me show you what this looks like. I know this is a little bit fuzzy because I've zoomed in. But in this example, we have a model named people, which is really imagine a table, and it has a column called ID. And we want to test that it's not null and unique. That's all we do is we literally write the words tests, not null and unique. And DBT, when you issue the command DBT test, DBT will generate the queries needed to test these assumptions. So you don't need to write any of that SQL. This is an example below of doing a relationship test. And here we're testing that the column account ID has a relationship to the table accounts and the column ID in there. And you can also specify severity such as error or warn. Warn would simply push you the information in the logs, but it would keep running all of your downstream models. Error, like I mentioned before, would just halt the process and say, okay, I'm not going to run anything dependent on these models. And finally, here's an example of accepted values. I'm going to pause here to see if we have any questions.
Yeah, we do. So we've just got a comment that like sort of the 4 tests are pretty limited. Is there any way to sort of extend this capability, especially compared to some of the tests that are in the Great Expectations library? So I can answer part of this, but I think, yeah, go for it, Carly.
Sure. I'm not familiar with Great Expectations, but I will talk about this last bullet point. You can test anything that's written as a query. So an example of using that might be, I want to test that our revenue is within 5% of what it typically looks like. So maybe I do like a rolling 7 days revenue, and I check to see if our revenue today is within 5% of what it is on average, or I compare it year over year, whatever that baseline is. Anything I can write as a query, I can write as a test. Hopefully that answers that question, but I'd love
Yeah, absolutely.
Comment.
And we've got a couple more people chiming in on the thread. We've got a talk coming up on how to use DBT and Great Expectations together. And we've also got a ton of packages that have more tests that you can easily add to your test library, including DBT expectations. So if you're in the chat, check out that thread for more info and relevant links.
Awesome. Thanks, Claire. All right, so core concept number 4. Documentation is accessible and easily updated. Has anybody documented their data stack before? My documentation is usually only when I'm about to leave a job. That's when I'm documenting everything. Otherwise, it just gets out of date. And so,
yeah, or it's aspirational when I have a team member join.
Right, or you get
half done.
Yeah, I document Looker. I document Looker, but otherwise, when I actually had a boss at a previous job say, "Can you document this?" and I said, "No, because it's going to get out of date, and there's no point."
Yeah.
With DBT, you're really auto-generating documentation, and it takes a few aspects into account. So the first aspect is you can document everything DBT knows about your project. First bullet point, descriptions. Now this would be manual documentation, and you would enter this in your YAML or your YML file, and this would be things like, I'm going to describe what this model or this table does, and maybe what these columns do if you want to get that ambitious, but typically, at least at the model level, that's extremely helpful. Then these next 4 bullet points, DBT is going to really automatically document just because you're building your project. So the first one is model dependencies. That's the lineage graph. You're seeing how all of your models flow. Your model SQL, this is what you're already typing to write your code, and DBT is going to include this in that documentation library. Your source data, this is your base data and where you're pulling from. And we're not talking about this today, but we can really show in our documentation how fresh this data is. And finally, your tests that you've written about your data. Any of those unique or nullable tests, we're going to show that in our documentation library so that everybody knows what we're running tests against. And finally, DBT is going to document just additional things that your warehouse is able to generate, and this varies by warehouse, but these are things that can pull from the information schema, column names and types, and table statistics. So let's give a quick demo, and this is publicly available. Actually, I already had that open. So if anybody wants to play around with this, go for it. This is our MRR playbook that Claire actually built, and this is a really good example of how to have really great documentation. I told her that my demo environment didn't look this good, so I'm going to use hers. So right here in this description, this is something that the developer has manually included. They put this in the YAML file so that everybody can see what this model is all about. Scrolling down here, these columns and these data types, these are automatically generated from your information schema. But these descriptions are things that you've manually written in your YAML file. So the idea is that as you're building out your models, you're going to create this workflow process where, oh, I include descriptions while I'm building out my models, and that's all I need to do. Everything else gets auto-generated for me. And so you can actually include this as part of your workflow. And I think we just had a package released recently, or I saw something that will actually check to make sure you're documenting and testing your code. And I don't know how it behaves, but it somehow tells you, hey, you need to go document and test your code, which I think is awesome.
Pretty cool. I haven't played with it yet, but I'm very excited.
Yeah, I haven't played with it, but I've been telling clients about it.
We'll have an office hours on it soon, I think.
Cool. And this column here shows the tests that you've written. If you hover over here, you see, okay, I've got a unique and a not null test on this ID column. And if I scroll down here, we can see the SQL I've written for my model. And if I click compile, it shows, okay, this is where it's actually querying from. This is the schema that this documentation portal is using. And I could copy this to my clipboard and paste it into Snowflake or whatever data warehouse I'm using. Now, what's really powerful about this documentation portal is, I don't know the right word, but I call it a portal, is that you can have non-DBT developers access this. So this is a really great place for report developers to use. So maybe they don't need to write DBT code, but they sure need to know how you're filtering your data and potentially how you're testing your data, because they might want to know, well, how did change category even get defined? In the old days, they maybe had to Slack or email a data engineer and say, hey, can you send me the query for how you did this? Or they're poking around in GitHub and they don't even know, where to look. Now they just come to your DBT documentation portal and hopefully can look around here and be pretty self-service.
Carly, can you just zoom in just a little bit on this one?
Yeah.
I've also shared the link in the chat if people want to sort of click through their own as well.
Does that help?
I think so, just a little bit, but there is that link too, so we should be good. Thank you.
Sure. Oh, and then right here is how you get to that lineage graph that I showed a little bit earlier.
Cool.
All right. So our final core concept today is that you can use macros to write reusable and modular SQL. This is something we've just never had as data developers. You typically have, certain logic and you need to copy and paste it over and over and over again. Macros would seek to prevent that. So a few things you can do by using Jinja, which is a very simple language. It's Pythonic. And even I picked it up being a SQL developer for many years. It's very easy for me to pick up Jinja. You can use control structures like if statements and for loops within your SQL. None of this ends up getting generated as within your SQL, but the code that it prints out becomes your SQL. This allows you to use environment variables in your project so that you can do different things for production deployments versus dev. For instance, a lot of times, especially if you're on a warehouse that's charging you for compute, when you're running in your dev environment, you maybe only want to run it for like 100 rows or 1,000 rows so that you're not spending too much time processing your code. You could actually write something like, if in dev, limit 100, limit 1,000. That way, when you are in production, it doesn't run that statement. Sorry, where was I? And then finally, you can abstract snippets of SQL into reusable macros. So these are kind of analogous. The analogy. They said expect bloopers today. So the analogy to this is functions in most programming language. So let me show you an example of how this works. Is this zoomed in enough?
I think so, but if you want to zoom just a little, I don't know if it's possible on Google Slides.
That's kind of is the most I can do.
Okay, we'll edit it for the next session.
Okay, thanks. So on the left side is the actual macro itself. Actually, let me back up and tell you why might you want to use this. So you've got a team of developers and you often find yourself converting cents to dollars. Without some constraints, you might have one developer doing it one way, another one doing it another way, using different data types, using different sizes, and you end up just getting multiple versions of this data type. You could have some documentation that says, please use this function to do it, but people aren't going to always pay attention to that. The alternative in the DBT world would just be, let's create a macro. So we've created this macro called cents to dollars, and it accepts a column name. And it just simply converts that column to numeric with a certain precision. And it divides by 100, of course. And you would just call this within your model by just wrapping that function around amount and including those curly braces to specify that it's Jinja. And it would actually just generate that SQL at runtime, which I'm not showing you here, but I recommend playing around with this. I often use the example of, I think, dates. Dates are often very, very varied across deployments. You know, some team members do it in one time zone, some people do it in UTC. You could just say, I'm going to have my Acme code date format and just standardize that across the board. And then when you're going through your typical code development workflow, hopefully when you get to approving that pull request, you're looking for things like that. Are we using our cents to dollar macro? Are we using our Acme date format macro? All right, so I lost my notes, apologize. Oop. I went full screen and then I lost my notes. Can y'all see still?
Looks good to me.
Okay, sorry about that. All right, so what I hope you come away with today is that the DBT workflow delivers higher quality analytics faster and cheaper. Analytics are higher quality because of the increased data coverage. You have better documentation, your data model is more accessible to non-developers, and you have testing and logging, making your data model a lot more resilient. Your analytics are now faster and cheaper to deliver. And finally, analytics teams and stakeholders are happier. This is hopefully because customers have the data that they need and they trust it. Analysts feel a lot more empowered because they have this better development workflow. And data engineers can now tackle more complex and challenging work. You no longer need data engineers to handle this plumbing. They're actually able to go on to like bigger and cooler things because DBT is handling all that plumbing for you. Okay, if you're interested in learning more, and also falling in love with DBT, I recommend going to courses.dbt.com. We now have a free DBT Learn on demand course out there. Highly recommend checking it out. All right, thank you for spending the time with me this morning. Feel free to DBT Slack me or email me or LinkedIn, all the above. I'd love to hear what you think.